And one of the things you might be doing is just learning how to ask people questions. So, for example, I've got some candles here, and I just want you to observe the candles really closely. So what is a difference between these two candles? Your observation will lead to you see a difference between the two candles. In the yellow, yeah. One's taller and one's shorter. Another difference, sir. Colors. This one's kind of like got that red and white stripe. This one is kind of tan. This one's, yeah, one more difference.
The small one looks like it burns a little bit less.
Ah, so it seems like the flame is a little smaller. That's another thing we could measure. Okay, so what I'm going to do now is, actually I can just use this. I'm going to light this third candle, and I want you to tell me a difference between this one and the other two. So what's different about this one? Yeah. The flame is, yeah, small, definitely smaller than that one. It's kind of the size of that one. Anything else? Yeah. It's kind of rounder, kind of bigger around in its girth. It's also edible. So now, how can a candle be edible? Let me see. Somebody new. How can a candle be edible? What do you think?
If you put like a wick inside food instead of just putting the wick inside actual candle.
Oh, okay. So you're saying that maybe the body of that candle, the cylinder of the candle, is actually, and here's another one, is actually some kind of food. Okay, so what kind of food would make for a good candle? Yeah. Yeah, that's a cheese stick. Okay, now, it looks like a candle. You observe it, it seems like a candle until I eat it. That's another observation. And then you're like, wait a minute, people don't eat wax. I can't swallow wax. He'd choke on that. So now you're like, okay, a cheese stick. Now, what do you think the wick is made out of, though? Wick in a candle is made out of a little piece of burning string. But I don't want to eat string. What could I make a wick out of? Yeah. Cotton candy. I think cotton candy is a good idea, but I think it would probably melt instead of burning. And also, you notice that doesn't look much like cotton candy, does it? Now, notice I have, whatever it is, I've already lit it a little bit to make it look like a wick. It's like a little bit black. That was another part of the trick, right? What do you think that might be? What does that look like to you? What does that look like to you? Okay. Let's think about things that burn. Let's see, string burns, certainly, wax burns, yeah. Oh, that's a really good, yeah, spaghetti noodle wouldn't be bad. Spaghetti noodle wouldn't burn for very long, though, and I need it to burn for a long time, so I need it to have a lot of energy. What kind of foods have a lot of calories? Think about what foods have a lot of calories. Yeah.
Bread?
Bread has a fair number of calories, yeah. That's exactly what this is. This is an almond. An almond has oil in it. It's the seed of the almond tree. The almond has oil in it because that's the energy that the seed is going to use to begin to grow the next almond tree, right? And if you've ever gotten almond butter or peanut butter and seen oil on the top, that's what is burning here. It's the oil in this thing that's mostly burning. And that allows it to burn for quite a good amount of time while I'm talking. And then you'll see that, and it takes a little bit longer to get it lit, so I usually have to kind of be careful with that when I'm doing this. And then while it's burning, I can talk, and it looks just like a candle. Now, it goes out as soon as it goes in my mouth so it doesn't burn my mouth. So it looked like one thing was happening. I was eating a candle. And another thing, really, I was just having a little salad. Cheese and almond salad. Okay. So, where is the energy from? Now stop and think. Where's the energy that I'm eating now from? Okay, let's stop and think for a second. Where did the cheese come from? I'm not talking about the store, but where did it come from in the world? Milk. Okay, where does milk get its energy from? Cow. Where did the cow get its energy from? Grass. Where did the grass get its energy from? The sun. So sun to grass, grass to cow, cow to milk, milk to cheese, cheese to Jeff, and now the energy is in me, and I can use that energy to speak. Right now, I'm warming your eardrums up. I'm making them vibrate with my voice. Put your hand on your throat. Bum, go bum, 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 bum. Okay, you just warmed up my eardrums with your breakfast. What'd you have for breakfast? Nothing? What'd you have for dinner last night? What'd you have for breakfast? What did you have for dinner?
Shrimp and broccoli.
Shrimp and broccoli. Let's think about the broccoli. Broccoli grows in the sun. You got energy from the broccoli, right? Maybe it had a little butter on it, might have come from a cow. That energy all came from the sun. Sun to you, you to your voice going broccoli. And broccoli wiggled in the air out to your eardrums. Her broccoli sound, broccoli, just warmed up your eardrums by making them wiggle. Energy connects us all. And so it allows us to do all kinds of things. And let me see where I'll put down my ring. Here we go. This is one of the things it allows us to do. It allows us to move. I can move my hands. I can spin this around. I could see these little discs here. I can use the energy of my breakfast, which came from the sun, right? To spin these. Now, energy never disappears. It always just changes form, like sun to grass to cow, and eventually to me through that cheese. Where does the energy go when I spin these? What do you think is going to happen when I spin these? Okay, what's going to happen?
They could go up the wheel.
They could go up the wheel, but where's the energy? Do you think they're going to just keep going around the wheel forever? No, so where's the energy going to go? I'll give them a spin in a second, but where's the energy going to go? Yeah.
Kinetic energy.
It's going to turn into kinetic energy. That's the energy of movement, but then where does it go? If they don't spin forever, let's try it and we'll figure it out. Okay, ready? Where'd some of the energy go? Into your ears, exactly, into your ears. So this is now making the ring vibrate a little bit, which is making the air vibrate, which is making your ears vibrate, which is allowing us to hear it, right? It's making our ears vibrate so that our brains can register that this is making a sound. It's also warming this up a little bit. How's it warming this up? Yeah, friction. Take your hands and do this. Hey, feel that? That friction is the heat that comes from the rubbing of your hands. That's your breakfast warming up the room. Warming up your hands and then warming up the room. So I spin those and some of the energy goes into sound, some of the energy goes into heat. Initially kinetic energy, the energy of movement, but not forever. Okay, now, why does this happen? How come those rings aren't stopping? Aren't they making a sound? Wasn't there friction on the ring? So how come they didn't stop while I was turning the big ring? Say again? I keep adding more energy. So I give them some initial breakfast, and then I give them I got to get my timing right here. There we go. I'm still giving them breakfast. I'm like, oh, there's the egg. Oh, now a little bit of my toast. Oh, some jam. You know, I keep having to add energy because the energy keeps going out in the form of sound and heating up the ring. And as soon as I stop adding breakfast, they stop. Okay, so we use the idea that we developed earlier, and now we've solved this problem. So science is always like building ideas. So what I want to do next is kind of think a little bit more about sound, all right? And I'm going to have you observe some sound first. And here's, okay, can you hear it? What must happen before I make a sound with this tuning fork? What's the first thing I have to do? I have to hit it, right? Now, once I hit it, something happens. What sound, what makes sound? Vibrations, okay? So this thing vibrates. So let's take a look at it vibrating. Can you see it vibrating? It's kind of hard where you are seeing it vibrate. I've got a better way to show you that it's vibrating. Watch. Right, so sound makes things vibrate. Or sound is the vibration of things, I should say, okay? Now, In this case, my vocal cords are vibrating. Bum, bum, bum. Do that again. Put your hand on your throat and go bum, 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 bum. Okay, you feel those vibrating. Now, I want to see if I can make that vibration do something to something else. And I have here a can, and I'm going to talk into the can. And on the end of the can, there's this mirror on a balloon, okay? What would be your guess as to what's going to happen to the mirror when I talk in this can? What do you think might be happening? Yes, sir? It might be vibrating because my voice somehow is getting to your eardrum. Well, it might be getting to this can first, the lid of this can. And you can keep pointing forward. I'm just going to just go ahead and feel it. Just touch the balloon. Can you feel it vibrate? Okay. So since it would take me a while to get around to everybody to show that this is vibrating, I want to point a laser at the mirror, okay? And you'll see that the laser bounces off and it's on the ceiling up there. Now, when I talk into the can, it vibrates the balloon. So my vocal cords are vibrating the air, and the air is vibrating the mirror, and the mirror is bouncing the laser. All right, so sound is a kind of movement, okay? Now, I want to think about the ways that sound could be different. So you could have sounds that are like this. And you could have sounds that are like that. What's the difference between those two kinds of sounds? Loudness. Okay, so if this is a vibrating tuning fork, and I want to model this versus this, what's different about what the tuning fork is doing when it's quiet versus when it's loud? What's different? Sure.
It's not making sound.
No, but it's making some. Listen, listen. I can hear that, can't you? Okay, now. What's different about what I did say? Yeah. It's not vibrating as hard. Yeah, as much. It's hard. So if I want to model that tuning fork, I could do it like this. Or I could do it like this. Right? I could do it hard or soft. But there's one other change I could make. Not how loud or quiet something is, which is how hard or soft the tuning fork is vibrating. What's the other change? What's the other change that I could make? Yes? Pitch. What is the difference between something that is high-pitched in terms of its vibrations and low-pitched? Yeah, the wave isn't actually going up and down. The four of you come up here for a second, real quick. Okay. Would you hold on to the chicken mask? You all go shoulder to shoulder right here, just like that. I want you to just hold this up in your left hand. Yep, just like that. Step away a little bit. When the pulse gets to you, you're going to hit it in the ear. This is me talking to the chicken. Ready? I would say, here, chick, chick, chick. That would be my throat vibrating, my vocal cords vibrating. And you all are representing the air. Okay? Now, the wave isn't going up and down. The wave is actually going back and forth. You're going to knock into you. You're going to knock into you. But wait until I hit. Okay, ready? Here's the first pulse. Whap. 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 Right? And I could do that faster. Whap, 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 whap. Or slower. Now, this would be the equivalent of a low-pitched sound. Whap. 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 This would be the equivalent of a high-pitched sound. Whap, and whap, and whap, and whap, and whap, and whap. Now, how would I, there's my chicken mask coming apart.
Keep this as like a souvenir.
Oh, yeah, sure. You can keep my, so the sound that I'm making can have two changes. How quickly or infrequently it's vibrating. And what was the other variable? How hard or soft it's vibrating. So this would be a quiet, low-pitched sound. This would be a quiet, high-pitched sound. This would be a loud, low-pitched sound. And this would be a scream! It's really fast, very fast vibrations, and very, very hard, which makes it loud and high. Okay, give these folks a hand. All right. So how can I change the vibrations practically? Well, with my voice, I can clearly make it loud or soft. How can I make this thing vibrate? Blow over it, right? So how do I change the vibrations in this? What's one way to change it? Yeah. How hard I blow the air. Soft hits. Hard hits. Now, how about if I want to change the pitch? Yeah. Fill it up with water. Okay, do you think the ones that these two have water of different amounts? This is a middle, this is filled quite high. Do you think that the one that's filled with water is going to be the highest or the lowest of these? Well, I'm going to give you a hint. Okay, we're going to come back to this in a second. I want you to watch something. Okay. So if I can find my scissors. I'm going to make another instrument. We'll come back to the bottles in a second. I'm going to make another instrument, and I want you to notice what happens. I cut a little mountain in it, like a little V in the top. If I blow through it, I can make it vibrate. Okay, so there it's vibrating. Well, I want you to watch what happens when I change this straw this way. Listen. Okay, so what happened when I changed the length of the straw? The pitch got higher, the frequency got, wait a minute, the frequency got faster, right? Because faster is higher, right? So the frequency got faster. So we can say small things tend to have a higher pitch or a faster frequency. With me so far? Small things, higher pitch, faster frequency. Okay, now let's think about a big bird. Caw, caw. Low pitch. Little bird. How about a big dog? Row, 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 row. Little dog. High pitch, right? How about a big person? Get out of my yard. A little person. I'm sorry, Mr. Johnson. A tuba. Row, 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 row. Big tuba. Little flute. They all correspond to the same thing. Now, I'll tell you what's vibrating in these bottles is the air. So which bottle is going to be the highest pitch? The one that has water or the one that doesn't? Yeah. The one that has water, right? So this one has a little bit of water. This one has a lot of water. Right? Corresponds to just what we said. Notice how we're building ideas. I'm going to test you out on something here. I've got a tube. It's a metal tube and a metal pipe. It has a screen in the bottom of it. I'm going to heat that screen up with a torch, and I want you to listen to what happens and figure out why it's happening. Okay? So there's a screen. It's like a heavy piece of metal screen, almost like what's in a window screen, but just heavier. And I'm making it red hot. Y'all see that? Red hot. Okay. Now, once it's hot, I want you to listen carefully to what happens. What can you tell me for sure about the air in this pipe? It's vibrating. You can tell me for sure it's vibrating. What else can you tell me about it? Why is it only go when it's vertical? Why does it only go when it's vertical? Yeah. It's rising. It can't rise out when it's like this. It's rising because it's hot. It's getting heated by that screen. So this is like an organ pipe. Anything that vibrates will make a sound. So we know that this thing is vibrating. So we can make some assumptions about what's going on in things we've never seen before based on stuff we've seen before.